Now let's do certain exercise questions starting from MCQs. By dehydration we mean the removal of water. Which is used for dehydrohalogenation? We know that this bromine water is used for bromination. What is bromination? The addition of bromine atom across the double bond. So this is not a correct option. Now this concentrated H2SO4 and Al2O3 are used for the dehydration. So these two also are not the correct option. So the correct option for this MCQ is the alcoholic KOH. This alcoholic KOH is used for the dehydrohalogenation. Which process produces an alkane? First one is the combustion. In the combustion, we have read that if it is a complete combustion, then our end products are carbon dioxide and water. So alkane is not produced, but alkane has been converted into carbon dioxide and water. So this is not a correct option. In the hydration, there is the addition of water. So addition of water will of course takes place in the unsaturated compounds, and because the addition will take place across the double or triple bond. So it will also not give an alkane. If the dehydration occur, then dehydration results in the formation of a double bond. So if a double bond is present, then of course it is not an alkane. We have the correct option, that is the hydrogenation. We know that when the hydrogen atoms are added across the double bond or a triple bond in an alkene and alkyne respectively, then that results in the formation of an alkane. So hydrogenation is the correct option for this MCQ. Which of the following substances does not react with the aqueous solution of the bromine? Now, if you look at all these substances, let's draw the structures. For C2H6 we have CH3CH3. For C2H4 we have CH2 double bond CH2. For C2H2 we have acetylene, that is HC triple bond CH. And for C3H6 we have CH3 CH double bond CH2. Now if you look at these three options, then you will see here that a double and the triple bond is present. Now since double and triple bonds are present, so this means that the bromine can get added to each of them. However, if you look at ethane, you may see that there is no double bond present. So this ethane will react with bromine only in the presence of a sunlight or UV. That reaction is also called as halogenation of alkanes. But this bromine will not get added to this chemical substance because here no double bond is present. So the correct option for this MCQ is C2H6. Now let's discuss some conversion questions. How can you convert ethene into ethane? Now the structure for ethene is, and you have to convert it into ethane. Now what is actually happening, that the double bond is converting into a single bond. And if you look at the hydrogen atoms on these two carbon atoms, then one hydrogen atom is being added to each carbon atom. So this means that there will be the addition of hydrogen, and we have read about this reaction. It is called as hydrogenation of alkene. So this hydrogenation of alkene takes place in the presence of nickel in the temperature 200 to 300 degree C. How can you convert methane into carbon tetrachloride? Now the structure for methane is CH4 and the structure for carbon tetrachloride is CCl4. So this means that all the hydrogen atoms in the methane has been replaced with the chlorine atoms. So this is a substitution reaction. We have read about this reaction in the halogenation of alkane. That what happens that first the methane reacts with chlorine in the presence of UV light or sunlight and first form the chloromethane. This chloromethane then further reacts with chlorine in the presence of sunlight to form dichloromethane. This dichloromethane again reacts with chlorine in the presence of UV light to form trichloromethane, which is called as chloroform, and it again reacts with chlorine in the UV light to form carbon tetrachloride. So this is how methane is converted into carbon tetrachloride. How can you convert ethene into glycol? We just read about this chemical reaction. This is ethene and this is glycol, ethylene glycol. This ethylene glycol is used as an antifreeze agent in the radiators of the car. Now, how did you accomplish this conversion? We use potassium permanganate. So, 2 moles of potassium permanganate plus 4 moles of water molecule. These substances react to give glycol plus 2 moles of manganese dioxide plus 2 moles of potassium hydroxide. How can you convert ethyl chloride into ethane? Now this is somewhat a tricky question. For ethyl chloride you have CH3, CH2, Cl. And for ethane you have CH3, CH3. Now you have not read about the direct conversion of ethyl chloride into ethane. If you revise the certain concepts, then you will understand or will memorize that for the alkyl halides we read certain reactions and some of those reactions were the belonging to the class that is dehydrohalogenation. What happens in the dehydrohalogenation? There is the removal of hydrogen as well as the halogen atom. Since the halogen atom here is chlorine, so one hydrogen and chlorine will be removed from this chemical substance. So let's do that first. Cl. Now this dehydrohalogenation takes place in the presence of alcoholic potassium hydroxide. When dehydrohalogenation takes place, then it results in the formation of an alkene. Now the end product that we want is an ethane. With this reaction we got ethene. Now you have to convert ethene into ethane, and that is very easy. What you will do? You will just add hydrogen atoms in the presence of nickel and 200 to 300 degrees C, and it will result in the formation of an ethane. So this is how you will convert the ethyl chloride into ethane. This is a two-step process. It involves two reactions. First reaction, dehydrohalogenation, and the second reaction is the hydrogenation. First reaction is the elimination reaction And the second reaction is the addition reaction. How will you convert ethyl bromide into ethene? This is very easy. We will just use the reaction of dehydrohalogenation, that ethyl bromide will be treated with potassium hydroxide in alcoholic medium to form this ethene plus KBr plus H2O. Write chemical equations for the reaction preparation of propene from these two compounds. Now first you have 1 propanol. Now from alcohols you prepared alkene by the process of dehydration. So I'm writing it like this. This hydrogen and OH will be removed and double bond will be introduced between these two carbon atoms. And this dehydration will take place in the presence of concentrated sulfuric acid. And the temperature will be maintained between 140 to 170 degree centigrade. So this is the structure for propene. So from propanol, this propene is synthesized by dehydration reaction. Now you have to prepare propene from the propyne. This is an easiest reaction. What you will do? You will add 1 molecule of hydrogen in the presence of nickel at 200 to 300 degrees C, and 1 hydrogen atom will be added to each of these two carbon atoms, and this is your propene. Write down the structural formula for the products which are formed when 1-butene is reacted with. Now let's do it one by one. In the first reaction, you are reacting it with hydrogen in the presence of nickel, so there automatically you will learn that this is a hydrogenation reaction. So the end product would be butane. Now you have now learned that how the structural formula are written, so I'm just writing the condensed form structural formula for these compounds. Now if you look at the second case, you have to react this compound with dilute alkaline aqueous potassium permanganate solution. Dilute alkaline potassium permanganate solution, then what do we get? Glycol. 2 OH group will be added across each double bond. Now 2 OH group will be added on these two carbon atoms, so we will get CH3, CH2, CHOH, CH2OH. So this will be the end product when this alkene reacts with dilute alkaline aqueous potassium permanganate solution. This structure is also named as 1,2-butane diol. When this compound reacts with bromine water, then what happens? That bromine atom will get added across the double bond. So we will get a compound like this. And for chlorine, we will get a compound like this. chlorine atom will be added across the double bond. Identify A, B, C, D in the following reaction. In the first reaction, we have propene. When the bromination of bromine takes place, then it results in the formation of compound like this. Bromine atom will be added across the double bond. Now in the next step, if you look at the next step, we are using alcoholic potassium hydroxide. So this means that there would be the dehydrohalogenation. When dehydrohalogenation occurs, then hydrogen and bromine atom will be removed from this chemical substance, and at the end we will get an alkene. So let's suppose we are taking hydrogen and bromine, and when these two bonds will be removed, then there will be the introduction of double bond between these two carbon atoms. We will get a compound like this. So by looking at the reagents, you may recall that what kind of chemical reaction is taking place here. Now in the second reaction, we have to react ethyl alcohol with the concentrated sulfuric acid. Now when the ethyl alcohol reacts with concentrated sulfuric acid, so this means that this is the dehydration reaction. When dehydration takes place, then it will result in the formation of an ethene. And in the second step, we are reacting this compound with bromine. Now when an alkene is reacted with bromine, then the bromine atom gets added across the double bond. So this will be our end product. So this is how you will be asked to complete the reactions. If you know about the chemical reactions given by each chemical substance, then you may easily complete these reactions just by looking at the reagents and the reactants. So this was all for today. Thank you for being with me. We will discuss about the properties and the preparation of alkynes in our next lecture. Till then, Allah Hafiz.